Hello everybody, this is a video for Math 13-14. Today we're going to be looking at how to find zeros of the polynomial function. We will also look and see how do you determine whether we have a multiplicity, and if we do, what it is. We will then look and determine what happens at each and every one of those multiplicities. So let's look at the problem. The problem says, find the zeros for the polynomial function and give the multiplicity for each zero. State whether the graph crosses the x-axis or touches the x-axis and turns around at each zero. Let me recreate the problem. F of x equals x cubed plus 4x squared minus x minus 4. For step number one, when we attacking or looking at the function, we need to determine what we're going to do. And the very first thing we're going to do is we're going to find the zeros for this particular polynomial function. And remember that to find the zeros of the polynomial function, this is where the function either crosses the x-axis or touches the x-axis and turns back where it came from and never crosses. Well, whether it touches or crosses or touches and turns back around, it still touches the x-axis. So we need to know the x-intercepts. And when we figure out the x-intercepts, we want to know what is the x when y is 0. So we'll take our function x cubed plus 4x squared minus x minus 4, and we'll set it equal to 0. Now notice that in order for us to find the roots, we have to factor this particular polynomial function. And as a hint for all of you, notice that the highest exponent of the function is 3. Not only that, we have 4 terms. Let's count. 1, 2, 3, 4. When we have 4 terms and the highest power is 3, a big hint, consider factoring by grouping. Again, when the highest power is 3 and you have 4 terms, consider factoring by grouping. Now, sometimes it works, sometimes it's not, but if it does work, it's sure going to save you a lot of time. When we factor by grouping, we will group the first 2 terms together and the last 2 terms together. As we group, we ask a question for each and every one of those groups. What is the greatest common factor? So when we look at the first group, what is the greatest common factor? In this case, the greatest common factor is x squared. So when I factor out x squared, from x cubed, I have x left. And when I factor out x squared from 4x squared, I have a positive 4 left. We'll do the same thing with the next group. The next group is negative x minus 4. We'll ask the same question. What is the greatest common factor? And the greatest common factor here is a negative 1. So when we factor a negative 1, look very carefully. When I take out a negative 1 out of negative x, x left. When I factor out a negative 1 out of negative 4, a positive 4 left. Of course, it will all equal to 0. Let's go back and double check, especially double check the second group that you factored. Let's look at the second group. Negative 1 times x. Is that going to give us negative x back? Yes. Negative 1 times 4. Is that going to give us negative 4 back? Yes. That means we factored correctly. Not only that, look what's inside the parentheses. Inside the parentheses, you have the same identical binomial, x plus 4. That means you're doing it right. Keep going and factoring. That x plus 4, when we factor that out, that becomes our first factor. And in the second set, the second factor, I call them leftovers. So if I take out or factor out x plus 4 out of the first term, I have x squared left. And when I factor out x plus 4 out of the second term, I have a negative 1 left. And of course, that equals to 0. So guess what? Now we factored our cubic. But we didn't finish factoring. We still have a quadratic factor. Look at the quadratic factor, x squared minus 1. Isn't that difference of 2 perfect squares? And that factors into x plus 1, x minus 1. Don't forget, we have a factor of x plus 4. And all of that equals to 0. Now we finally completed factoring of this particular polynomial. Now our goal is to actually find and answer the question. Find the zeros. Step number 2. When we find zeros of a polynomial function in factored form, we take each factor and we set it equal to 0. When we take x plus 4 make it equal to 0. Let's solve for x. Subtract 4 from both sides. Our x is a -4. Let's solve the other two. Subtract 1 here from both sides, and x equals -1. When we solve the third one, add 1 to both sides, and x is 1. We have 3 zeros. Okay. Now, we answered the question for finding the zeros, but we didn't answer the question on finding the multiplicity. So step number 3, multiplicity. Okay. Let's look at the multiplicity for the first zero, x equals -4. To find the multiplicity, we go back to our factored form of the function and find out how many times we see the factor of x plus 4. Another way of saying, look at the exponent on x plus 4, and the exponent is 1. Okay, so we have a multiplicity of 1. All right, so I'm looking at multiplicity of 1 for x equals -4. Now remember, as a side note, let's go back and review quickly rules of multiplicity. We have 2 types of multiplicity, odd or even. Okay? If the multiplicity is odd, the graph will touch x-axis and cross the x-axis. So touch and cross. When we're looking at the multiplicity that happens to be even, the graph will touch x-axis, but will not cross. So we'll say touch and turn. Now going back to our problem, for x equals -4, multiplicity is 1. 1, number 1, is an odd number. So hence, we have an odd multiplicity. When the multiplicity is odd, the graph will touch and cross the x-axis. Let's look at x equals -1. Go back and look at the exponent on the factor x plus 1. The exponent is 1. Again, multiplicity of 1. The graph will touch and cross. Let's look at x equals +1. Go back and look at the exponent on x equals x minus 1. The exponent is 1. Hence, multiplicity of 1. The graph will touch and cross. So our function happens to touch and cross at every one of these particular roots or zeros. Going back and making sure that we answered all of the questions, find the zeros for the polynomial function, we did that. Give the multiplicity for each zero, we've done that. Have we stated whether the graph crosses the x-axis or touches the x-axis and turns around at each of the zeros? Yes, we did. The problem is finished.